Well, good evening. And my God, it is so exciting to see this kind of audience tonight. I am so pleased you all took time to come out this evening to hear the beginning of a new series of talks, short talks, that I hope will be impactful for you. I'm particularly excited to have you all continue your unwavering support of Texas Biomedical Research Institute, particularly in this year, as Corbett said. We're going through a very exciting and transformative phase in the history of the Institute. And I think we'll all be proud of where we'll be going with this Institute plan, and I hope to be able to share with you a lot of exciting things going forward. So how I want to start this is to say that in addition to being a biomedical researcher working on infectious disease threats for the past 30 years, I also, until recently, was a practicing clinician, an internist, and an infectious diseases subspecialist. And how I'd like to start this tonight is I want to tell you about a patient that I managed early in my career at the University of Michigan. This case had a great impact on me, and it makes several illustrative points that I'll be highlighting in this talk this evening. The talk begins with a 37-year-old mother of 2 children. This woman was the picture of health, and in fact, she was a personal trainer. One day she woke up and she felt a lump in her breast. The next day she went to the doctor and she received the very difficult diagnosis of breast cancer. Shortly thereafter, she underwent a double mastectomy and had several rounds of chemotherapy. After several weeks of chemotherapy, she and the family went to the doctor's office, and the doctor gave her news that every cancer patient wants to hear. And that is that I think we've cured you. We don't see any cancer cells in your body. And the family was ecstatic. 2 weeks later, the patient wakes up from sleep one morning and has fever and feels fatigue. Her husband immediately notices that she doesn't look well and takes her to the local emergency room. By the time she's in the emergency room, she's unconscious and has to be intubated, a tube inside her lungs, and is whisked off to the intensive care unit. She's given the diagnosis of a life-threatening disease called septic shock, which is due to a serious bacterial infection. Maybe some of you know this infection. The next day, her family is given worse news because she was put on antibiotics for that bacterial infection, but the next day, they found out that she had what's called a superbug. The bacteria that she was infected with was resistant to just about every antibiotic available to treating this infection. Well, our patient, Mrs. Jones, struggled for the next 30 days in the intensive care unit, and despite all kinds of antibiotics and other supportive therapy, ultimately had her organs shut down and she died from this infection. The next day, the local newspaper highlighted her death. The front page said, we have the tragic story of a young woman who died of breast cancer. In fact, there was very little attention to infection in the story. So let me start by making several points around this case. First and foremost, we really need to start thinking about, discussing, and performing infectious diseases research differently. We have to have a greater appreciation through our research efforts of the important links between infectious diseases and other disease states. Only when we begin to think about these diseases together, I think, can we solve the problem. Now, in this particular case, the links between infection and cancer are in fact very strong. It's estimated that about 1/3 of cancer patients will suffer or die from infection. Research is now showing almost on an annual basis that molecules that are produced by the infectious agents that come into our bodies can trigger a variety of infections. So the links are pretty strong. The next point I want to make is we don't actually die of bugs entering our body. We don't suffer and die from that. In fact, we suffer and die from the ability of our body to fight the infection. This is the immune system. And when the immune system is activated to fight the infection, there's a concept that emerges called inflammation. In fact, it's inflammation, our body's reaction, that leads to fever, night sweats, if you have a pneumonia cough. So this is really an important concept. Now here's the key point. If you're otherwise a healthy human, then the amount of inflammation is limited. The amount of inflammation that occurs is limited to the local site of infection, and that inflammatory response is short-lived. In other words, you're sick for a little while, and then you get over your infection and you're cured. Here's the problem. The problem is if you're not a healthy host, for example, Mrs. Jones, our patient, who has a weakened immune system, we cannot control the infection properly, then inflammation goes awry. We see the same scenario in people who have other so-called comorbidities or disease states like type 2 diabetes, or the elderly, or after transplant, there's a whole variety of immunocompromised individuals. In this case, the inflammation becomes chronic and unchecked. Unchecked chronic inflammation has been associated with a variety of other diseases, such as autoimmune diseases, inflammatory bowel disease, rheumatoid arthritis, etc. So again, a link between, in this case, the body's reaction to infection and other disease states. The next point I want to make is that this patient had a superbug. And there are many now of us in infectious diseases who feel that we're in the middle of a perfect storm. There is an increasing rise in the number of highly resistant microbes for which we have no treatments. Also, since the 1980s, there's been a tripling of outbreaks due to infectious diseases. And finally, the number of susceptible individuals to infection is increasing. In fact, the population is aging, and the elderly population will become more and more prominent on the planet, and as a result, more and more susceptible individuals will occur. This perfect storm then sets up what many economists think is a major problem with infectious diseases going forward. So it's been estimated that by 2050, the number one killer of humans on the planet will be infectious diseases, to the cost of approximately $100 trillion to the global economy. So the impact of infectious diseases is actually quite severe. Now, what does all of this have to do with Texas Biomed and San Antonio? And why did I elect to come to San Antonio to lead Texas Biomed? Well, in fact, I'm an infectious diseases researcher. The area of my research is tuberculosis, which is actually a contemporary scourge and has been for many, many years. But the challenges associated with infectious diseases are much larger than any one disease. And so we have to think much more broadly about the way we're going to tackle this problem if we're going to solve it. One of the things we need to do is change the scenario of how we approach research in infectious diseases. Currently, it's reactive, and we react to a crisis. So for example, currently we're in the influenza outbreak, and it's a crisis, and we have people dying of all ages due to influenza. So going forward, I think we really need to be proactive in our approach, and we need to work together more effectively. I'm here in San Antonio because I think Texas Biomed in San Antonio has the right tools, resources, and mindset so that working together we can get a handle on infectious diseases threats and combat this major problem in the world. So what am I really talking about when I'm talking about us working together? I'm talking about the concept of team science. Team science has become extremely important in making major biomedical research discoveries. What does it mean? It means that we can no longer work in isolation in individual labs, solving one typically small problem at a time. Instead, we need to bring together teams of investigators working on new technologies and innovations to solve big problems together in a more efficient and effective manner. So for example, at Texas Biomed, we are working to bring together virologists and immunologists, working with cell biologists, structural biologists, geneticists, data science people, so that we can develop new innovations and technologies and move our approaches to controlling infectious diseases better. So for example, we're not just interested in how a bug comes into our body and causes infection. Instead, we can use new technology to image or visualize infection in model systems such as animals, so really get to the site of infection. Our technologies are now allowing us to identify gene targets. Gene targets become the focus point of new approaches for diagnosis, therapy, and vaccines. Now, beyond the research community is a collaboration that's required that goes outside the bench and scientists, and it goes out to the community in the private sector. So these collaborations need to extend to businesses, to industry, and to private individuals. Why is this so important? This is important because working together, we can identify innovative approaches to, for example, new sources of funding and resources that are critical for biomedical research, since we, generally speaking, are under-resourced. It can bring new tools and new fresh ideas to the table working together, so that, again, we have a better chance of solving the problem of infectious diseases with new diagnostics, therapies, and vaccines. Why am I in San Antonio? Because I think, in my career, I find that San Antonio is one of the most collaborative communities when it comes to biomedical research that I've seen in all the states that I've worked together. And this is clearly an edge for us. But here's what's important. We have to capitalize on that edge. We need to take advantage of the community working together with the scientists in Texas Biomed so that we can solve what I think is the greatest public health threat in the coming decades. That is the threat of infectious diseases.